Good morning friends. Today I am going to explain what is spherical aberration. In the last class we discussed about the what is chromatic aberration. That is, if the light is not monochromatic, then the image formed by the lens is a blurred image. So that particular defect is known as the chromatic aberration. Now here in the spherical aberration, after taking a monochromatic light, then that time also we are not getting a correct sharp image. So that particular defect is known as the spherical aberration. That is not the inability of the lens to form a point image of an axial object is called a spherical aberration. So what's the reason? Okay, so the reason is, here we know that the lens is divided into a different zones. Okay, first of all, okay, and we know that the radius of each zone will be different. Okay, and next, here the light rays which are falling nearer to the principal axis, this is nothing but a middle one is the principal axis. The light rays which are falling nearer to the principal axis is called the paraxial rays, and the light rays which are nearer to the rim of these lenses is called the marginal rays. So marginal rays will be focusing at first, and next parallel rays will be focusing at further distance from the marginal rays. So here, if you move the screen in between IM and IP, then the image will be not a correct or sharp image. So that particular defect is known as the spherical aberration. That is the inability of the lens to form a point image of an axial object is called the spherical aberration. Okay, for that purpose, let us consider a point source O of monochromatic light on the axis of the convex lens as shown in the figure. Okay, so just I told you this is the point object. So the light rays which are nearer to the principal axis, paraxial rays. The light rays which are nearer to the rim of the lens is known as the marginal rays, and the marginal rays will be focusing at first and next paraxial rays IP, and this is the screen which is moving in between IM and IP. Okay, now here the rays which are incident near the axis are called the paraxial rays. They come to focus at point IP. They come to focus at IP, these paraxial rays. Okay, now the rays near the rim of the lens are called the marginal rays or the peripheral rays. They come to focus at point IM. Okay, at point IM. The intermediate rays are brought to focus between IM and IP. So in between all the rays will be, the intermediate rays will be brought to focus at between IM and IP. Okay, now from the figure it is clear that the paraxial rays from the image at point which is at larger distance from the lens when compared to the focusing point of the marginal rays. Okay, so these are IPs at a larger distance compared to the focusing point of marginal rays. Okay, thus the image is not sharp at any point on the axis. Okay, so if you move the screen in between at point, if you put at point IP or at point IM or at point IP or in between, the image will be not sharp at any point on the in between the IM and IP. Okay, this defect is known as the spherical aberration. So what's the reason? Just I wrote here the reasons. Is first reason is the lens can be supposed to be divided into number of zones, or as the focal length is slightly varies with the radii of the zones. Different zones have the different focal length. So just now I told you, that is, first of all, the lens is supposed to be divided into a just like a number of zones, and here the focusing point will be different for the different zones like this here. Okay, so first point is what? That is, the lens is supposed to be divided into a different zones, and different zones focal length is different. Okay, so different zones have different focal length. Because of that one, the first reason. And the second reason is the focal length of marginal zone is lesser than the focal length of the paraxial zone. Hence the marginal rays are focused at first. So focal length of this one is lesser than the focal length of this zone. So the light ray which is passing through this marginal zone is called the marginal rays, and the light rays which are passing through this particular zone, which one, that is paraxial zone, is called the paraxial rays. Okay, so this is the second reason. And the third reason is the marginal rays suffer a greater deviation than the paraxial rays. The third point is the marginal rays will be suffers a greater deviation compared to the paraxial one. Okay, so thank you. For more videos, subscribe my channel Physics.